A vector is a line segment with an arrow on the end of it. If I wanted to represent a vector of 10 meters to the east, I may draw it like this. If I wanted to represent a vector of 15 meters to the west, I may represent it like this. Notice it's about 1.5 times the length of the 10-meter vector. We want to do that as much as possible, draw it to scale, so that a 15-meter long vector is about 1.5 times the length of a 10-meter long vector. Let's say that I got another vector that's 10 meters to the south. Well, I'd represent that one like this. If I wanted to add those three vectors together, it's important to recognize that I don't just say 10 plus 10 plus 15 gives me 35. If I was adding scalars together, 10 plus 10 plus 15 would give me 35. But when I'm adding vectors in 2 dimensions with an x and a y, I have to A, draw a vector diagram, and then B, turn that vector diagram into a, what's always the goal? A right-angled triangle. So, how do I draw the vector diagram first? Well, remember that all three of these vectors, doesn't really matter what order I add them in, but they have to be drawn head to tail. So I'm going to draw the 10-meter one first. Okay, there's the first one. I'm going to draw the other 10-meter long vector. And then I'm going to draw the 15-meter long vector, and it's going to look like this. Is this drawn okay? Yeah, this is drawn head to tail, arrow to back of the vector. The resultant vector, which is the sum of these vectors, is drawn from start to finish. And I'm going to label that R. That's not a triangle, let alone a right-angled triangle, but it is a vector diagram. How do I turn that vector diagram into a right-angled triangle? I go over here and do my x and y components. You guys are doing a really, really good job at this yesterday. How much of that first vector, that first 10 meters, is x component? 10. How much of its y component? 0, because it's all on the x-axis. How much of that second one is x-axis? 0. How much of its y-axis? Negative 10 meters, because it's 10 down. How much of that third one is x component? Negative 15, because it's along the negative axis, negative x-axis, so it's to the left. And how much of its y-axis? 0. So let's add these up now. 10 plus negative 15 gives me negative 5.0, and 0 plus negative 10 plus 0 gives me negative 10. Now I combine them. I'm going to say 5 to the left and 10 down. And then my resultant vector is going to look like this. That resultant vector looks a lot like the resultant vector that we had drawn over here, right? I can find that now because I have a right-angled vector diagram. Now, I could draw it like this. I could draw it 10 down and 5 over. That would work, right? Because it's still drawn head to tail. That would be legal. The only difference there, R is going to be the same value, right? The only difference is going to be the direction. This theta angle, always measured from the start, will be different than this theta measured from the start. They're both okay, though. Just like yesterday's example, I said, I'm 2 meters from the front of the room, I'm 6 meters from the back of the room. Two different numbers, both correctly describe where I am. Okay, here, two different numbers can both correctly describe the direction of R. I'll do it the first way. Okay, I'll do it this way. First of all, let's solve for the value of R. How do I do that? A squared plus b squared is equal to c squared, or c is equal to the square root of a squared plus b squared. R is equal to the square root of 10 squared plus 5 squared. So we're going to say that's a square root of 125, which is going to give me, I believe it's 22 point something. What is the square root of 125? 100 and, no, it's 11 point something, isn't it? Thank you. 11.18 or 11.2 meters. Now, solve for theta. Remember we talked yesterday, we did a little trigonometry review, opposite adjacent hypotenuse. The hypotenuse is always the longest side. So the hypotenuse here is R. Usually the hypotenuse is R, although not always. It is always the longest side. So this is hypotenuse. The adjacent side is the other one that touches the angle. It's the short one that touches the angle. So this would be adjacent, and this would be opposite. I have the adjacent and the opposite side, so I'm going to use the tan function. Theta is equal to the inverse tan of opposite over adjacent. Or it's equal to the inverse tan of 10 over 5. What's the angle work out to be there? What is it? 63.4. So we'll say 63.4 degrees. Now, how do we express that? 63.4 degrees, what of what? Forget about the word of. We don't like that word of. We like the word from. Am I measuring this angle from the west or from the south? I'm going west and south, right? The only question is, where am I measuring my angle from? Am I measuring it from the west, or am I measuring that angle theta from the south? From the what? So it's south from west then, right? I'm measuring it from west, south from west, or we would express that as south of west. Just replace the word from with of. Make sense? Okay, you had one question for homework to work on last night. It's a board problem, and it said we wanted to add these vectors together. 200 meters to the east. We wanted to add 400 meters to the south. We had 300 meters to the east. We had 100 meters to the north. Man, it keeps going here. And 150 meters to the west. We wanted to find the resultant vector. We wanted to add these vectors together. We wanted to find the sum of all these vectors. All mean the same thing, right? Sum, resultant, add, they all mean the same thing. Let's draw it first. We got 200 meters to the east. And then we have 400 meters to the south. Head to tail. Yeah, go ahead. Yeah. Then we have 300 meters to the east. Head to tail. Then we have 100 meters to the north. And then we have 150 meters to the west. Is that good? They're all drawn head to tail? Absolutely. It's not a triangle, let alone a right angle triangle. So let's do our x and y's now. There's a lot of them here. What's the x component of the first one? How much of that 200 is x? 200. How much of it's y? 0. Second one, how much of that 400 is x? 0. How much of it's y? Negative 400. Good. 300. How much of it's x? 300. How much of it's y? 0. 100. How much of it's x? 0. How much of it's y? 100. Next one, 150. How much of it's x? Good. Negative 150, and 0 of it is y, of course. 200 plus 300 is 500. Subtract 150 is 350. And the second one, negative 400 plus 100 gives me negative 300. So I'm going to draw this now. 350 to the right, and 300 down, right? Drawn head to tail. And now I draw that resultant vector, and hey, it looks a lot like that first one. It should. Now I can find the value of r pretty easily. Where am I going to put the angle in? I got three places here I could put it. Position 1, position 2, or position 3. Position 3, because 3 is at the start of my diagram. So always do it at the start of the diagram. All right, let's find the value of r. Using the Pythagorean theorem, r is equal to the square root of 350 squared plus 300 squared. Let's do that one on our calculator together here. $350 squared plus 300 squared. Okay, let's square root that. We end up getting 461. And we're going to find theta. We have, what side of the triangle is this? Hypotenuse, opposite, or adjacent? Adjacent, because it's the small side touching the angle. So we're going to say it's the inverse tan of opposite, 300, over adjacent, 350. Let's solve for that one. Hey, what's a little check that we like to do in our calculator the first time we use it? Sine 90. Sine 90. It's a good idea to do every time you come to class and you have to do an angle. You don't need to do it. If you do 10 different angle calculations, you don't need to do this 10 times. Just do it once at the beginning of class here. Let's say sine 90. I get 1, which means I'm in degree mode. If I don't get 1, then it means I'm in radian mode and I got to switch. So I'm good here. I'm going to say second function tan, inverse tan of 300 divided by 350 ends up giving me an angle of 40.6 degrees. Now how would I express that? 40.6 degrees. What of what? Forget about of. What from what? Where did I go here? Well, I went south and I went east. Francis, I went south of east or south from the east, right? It's measured, the angle is measured from the east, and then I go south from the east or south of east. Had you drawn the y-axis first here, we would have gotten about 49.4 degrees, but it would have been east of south, and that would have been equally as correct. Good? Feel okay? All right, good. What happens if I want to add 2 vectors together, or 3 or 4 or 5 vectors together, and they're not all on either the x-axis or the y-axis? So in other words, I've got this vector that I want to add to this vector. That's tougher. That's tougher to deal with. I want you to repeat after me these 5 words, okay? And I want you to always remember these 5 words when you see what I call a funny angle. A funny angle is 30 degrees. Well, a funny angle isn't 0 or 90 or 180, but any other angle is a funny angle. 89 degrees is a funny angle. 45 is a funny angle. 30 is a funny angle. 87 is a funny angle. 2 is a funny angle. 0, 90, 180, they're okay. Repeat after me. I don't like funny angles. I don't like funny angles. If you see 30 degrees, say to yourself, I don't like funny angles. I got to get rid of a funny angle. So here's what you do. Okay, here's what you do. You've got to take, let's say you have this one vector, 10 meters at 30 degrees. You've got to take it and change it into something like this and something like this. Right? It's going east and north, so let's get the east part of it and the north part of it. That make sense? Now, I'm not asking you, does it make sense how you get that part of it? Okay, I'm not asking you about that yet, because that's still coming. Does it make sense that we need to change this into this and this? Do you understand that that's effectively the same thing? Now, how we do that, that's going to come in just a moment here. Take a look up at the board here now. Remember xy plane, okay, x-axis, y-axis. Couple quick little easy ones first that don't have the funny angles, and then we'll get back into dealing with the funny angle. How much of this one's x? Well, 10 meters. And how much of it's y? 0. How much of this one's x? 0. How much of it's y? 200. Easy, right? X is negative 50. Y is 0. X is 0. Y is negative 35. Easy, easy, right? You don't even need to write this down if you don't want to, because we've done enough of this. X and y components of these vectors, easy. But what about the x and y components of these vectors? In order to get the x and y components of these vectors, here's the strategy. Turn the vector into a triangle. Turn the vector into a little triangle. So if I've got 100 meters up at 30 degrees, this would be 30 degrees, by the way, north of east. 30 degrees north of east. Draw a triangle around the angle. So in other words, make a triangle, make sure the angle is inside the triangle. We don't want to draw it like this. Well, that's a triangle, but the angle isn't inside the triangle if I draw it like that, right? That makes sense? If I have it drawn like this, that doesn't help us because the angle is outside of the triangle. You need to draw a triangle, so that a right angle triangle, so that the angle is inside the triangle. Now, label this x and label this y. Does it make sense? Y it's x and y it's y. Now what you got to do is use some trigonometry to solve for x and y. Remember our trig functions, SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. Which side of the triangle is the 100? That's the hypotenuse, because it's the longest side, right? The longest side is the hypotenuse. Which side of the triangle is x? It's adjacent. It's the short side touching the angle. Which side is y? Opposite. It's the one that's not touching the angle. Do you see that? X is touching the angle right here. Y is not touching the angle. So this is touching the angle, but because it's the longest side, it's the resultant. The short one touching the angle is the adjacent. Okay. I'm going to write down SOHCAHTOA up here just to refresh your memory on it. Sine is opposite of hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. How am I going to find the value of x there? How am I going to find the adjacent side given the theta and the hypotenuse? Which trig function goes with theta, hypotenuse, and adjacent? Cosine. So let's say cosine 30 degrees is equal to adjacent over hypotenuse. Or let's say cosine 30 degrees is equal to x over 100. Adjacent over hypotenuse. X becomes 100 times cosine 30. Right? Take that 100 up by multiplying. Gives me 86.6, I believe that's 0.602 meters. Somebody check that, but I'm pretty sure it's 86.602. Now, which side of the, Which side of the triangle is the y component? Opposite adjacent hypotenuse. Opposite. So given hypotenuse, and I want to find the opposite, let's use sine. Sine 30 degrees is equal to opposite over 100. 100 times sine 30 ends up giving me exactly 50 meters. So this becomes 86.602 meters, and this becomes 50 meters. As far as I'm concerned now, this vector doesn't even exist, which is good news for me. It's good news for me because I don't like funny angles. So I want to get rid of it. I want to turn that 100 meters into 86 this way and 50 this way. We know how to deal with these. Look, we did right here. Right? These are easy to deal with. It's the 100 meters at 30 degrees that wasn't easy to deal with. So I'm going to erase that, but remember that 100 meters is gone now to us. It is, that 100 meters is dead to us. We're never going to use that 100 meters again. We've replaced it with 86 to the right and 50 up. Yep?
Instead of using sine to find y, could you use the Pythagorean theorem?
Yes, you could. Instead of using sine to find y, could you use the Pythagorean theorem? Because you have the hypotenuse, you have basically a squared, a and c now, and you just be solving for b. The danger of that is this. If you made a mistake with calculating the x component, which is the adjacent side, and you use the Pythagorean theorem, well then you're going to automatically get the y component wrong as well. If you go back to using trig functions, you can make a mistake with x and still get y correct. So I would suggest you don't use the Pythagorean theorem, but it will work if you do everything correctly. And you don't round. Okay, if those are rounded numbers, then the Pythagorean theorem is going to give you an answer that's off of it. Let's take a look at this one. Okay, I see 20 meters at 30 degrees. This would be 30 degrees east of south. Right? Going east, going south, but the angle is measured from the south, east from the south, or east of south. Whatever, 30 degrees, 5 words, what are they? I don't like funny angles. So I get rid of it. Let's replace that 30 degrees, 20 meters, 30 degrees with this. This is y. This is x. Solve for x is solve for y so that I never have to use that 20 meters. Let's say sine 30 degrees is equal to opposite over hypotenuse. What's the opposite side here? Y or x? X, because it's not touching the angle, over the hypotenuse. 20 times sine 30 is exactly 10. Now let's say cosine 30 is equal to adjacent over hypotenuse, which is the y component over 20. And y ends up being equal to 17 point, I want to say 3205. Somebody double check that. 20 times cosine 30. So remember, y is, well, that's 10 meters. X is 17.3205. As far as we're concerned, 20 meters is gone now. I've got two straight, easy vectors to deal with on the x-axis and the y-axis, and the 20 meters is gone. Yeah, sorry, thank you, you're right. I've calculated x to be 10 here, but then I labeled it on the vector diagram wrong here. So x is 10, y is 17.3205. Thank you. Here's what I'd like you to do right now. Go to your worksheet that I gave you the other day and do questions 6 to 13, please. Those questions 6 to 13 all involve not adding vectors, but just finding the x and y components of vectors. There's a couple of them that are really easy, 6, 7, and 8. Really easy because it's just straight up and down or left and right. But then it gets a little bit harder with the funny angles. Remember, whenever you see a funny angle, repeat those words in your head. I don't like funny angles. Draw a triangle around the angle. Use trigonometry, sine or cosine, to find the x and the y components. I want to do question number 10 here, just as another example here, just to make sure that we're on the right track as you're working on these questions now. Number 10 says we got 50 meters. 50 meters at an angle of 60 degrees. That 60 degrees, by the way, would be east of north, because, look, we're going east and we're going north. We're going north and we're going east. Well, the angle is measured from the north, so we'd say it's east from the north, or east of north. Now, I don't like that funny angle. Okay, we see any kind of funny angle other than 0 or 90 or 180 degrees, and we repeat those 5 words. I don't like funny angles. So let's get rid of it. Let's draw a triangle around the angle. And let's label this one x and let's label this one y. And now let's find x and y components. Which side of the triangle is the x component? Is it opposite, adjacent, or hypotenuse? It's opposite. What is the side that we have given to us, the 50 meters? Is that adjacent or hypotenuse? It's the hypotenuse. So the side that's not touching the angle is the opposite. The long side that is touching the angle is the hypotenuse. I've got opposite and hypotenuse. Let's say sine 60 degrees is equal to opposite over hypotenuse. Does that make sense? We're going to say 50 times sine 60, I believe, is 43.3 meters. And we're going to say cosine 60 degrees is equal to adjacent over the hypotenuse. Adjacent over hypotenuse, that's the y component. That's the short side touching the angle, divided by the hypotenuse. That's the long side. And y ends up being 50 times cosine 60 gives me, I believe it's exactly 25.0 meters. So there we go. We don't need to worry about the 50 meters anymore. It's gone. It's gone. Like, as far as we're concerned, it doesn't exist anymore. All we care about now is the fact that we have 43 meters to the right, and then we have 25 meters up. Now I'm going to erase this, just so you can see the original question there. But whatever is not in green becomes irrelevant to us. How many people got 43 and 25 for that? Good. Good. All right, keep working. We'll give you another few minutes, and then we'll take a look at another one, perhaps. Okay, let's go through the rest of these quickly, and then we'll take a look at kind of putting it all together, adding vectors with funny angles. Okay, we've added vectors, we've dealt with funny angles, but we haven't added vectors with funny angles. We'll put it all together in just a couple minutes when we're done here. I'm going to erase number 10, but let's remember that I've finished number 10, so I won't do that again. The x component of number 6 is just 25, and the y component is 0. Easy, right? Number 7, the x component is 0, the y component is negative 8. Good. Number 8, the x component is negative 100. Good. And the y component is 0. Good. Now we get into the harder ones here. Okay, question number 9. We've got a funny angle, and guess what? I'm pretty sure you guys are like me. I don't like funny angles, so I want to get rid of it. I draw a triangle around the angle, label this x, label this y, and x is the adjacent side, so I'm going to say cosine 30 degrees is equal to adjacent over hypotenuse. And I'm going to say, there's my x side, I'm going to say sine 30 degrees is equal to opposite over hypotenuse. So there's my x, 8.66, and there's my y, 5.0. How many people got that? Good. We did number 10. Let's take a look at number 11. Don't like funny angles here any more than I liked it before. Got 60 degrees. Let's draw a triangle with the arrows. Don't skip the arrows. Okay, some people like to do this. They just, I'll draw a little triangle. I'll skip the arrows. I don't need to follow the rules. Okay, I'm smarter than everybody else. No, you're not. Okay, we're all smart here. All of us are. Otherwise, we wouldn't be here. We all need to draw the triangle, and we all need to draw the arrows. This is x, this is y. X is the opposite adjacent or hypotenuse. It's the adjacent, so we're going to say cosine 60 degrees is equal to adjacent over hypotenuse. X ends up being equal to 50 meters. And we're going to say sine 60 degrees is equal to opposite, or y over hypotenuse, 86.6. Do you notice my angles are usually 30 or 60 degrees? Anybody know why I do that? So that I don't have to memorize all these different numbers, right? I memorize that sine 30 is 0.5 and that cos 30 is 0.866, right? It just makes it easier. I don't have to punch it into my calculator every time. I'm not calculating those trigonometric ratios in my head. I'm remembering 30 degrees and 60 degrees. That's it. Okay, let's take a look at number 12. 12, 30 degrees. Don't like funny angles. So let's draw a triangle around the angle so that the angle's inside it. Let's label this x, label this y. Let's say cosine 30 degrees is equal to adjacent over hypotenuse. X is 40, cosine 30. I want to say 32.99. Anybody have that? 40 cos 30? Gives me 34.64 meters. There's the x component. Now the y component is the opposite side. Sine 30 degrees is equal to y over 40. Y ends up being equal to 40 sine 30, which is exactly 20 meters. There we go. Don't have the 30 degrees. Don't have the 40 meters anymore. I've replaced it with 34.64 to the right and 20 meters down, which is a lot easier to deal with when I go to add vectors together, as we're going to see in just a couple minutes. Finally, number 13, the last one that I asked you to do, 30 degrees, funny angle. I don't like funny angles, so we draw a triangle around it, label this x, label this y. Cosine 30 degrees is equal to adjacent over hypotenuse. Gives me 69.28. And the y component, we're going to say sine 30 degrees is equal to opposite, which is y over the hypotenuse. Y ends up being exactly 40 meters. And there we go. Good? How many people got all of those right? Good. Okay, if you're having a little bit of trouble, make sure I know about it so that I can help you with it, okay? Now, the question is, how do I put that into play for questions 14, 15, and 16 when I go to add vectors together? So for instance, I'll give you an example here, not one of those problems that was on the worksheet. For instance, I have a vector right here. Let's make it 100 meters. I have another vector right here. Let's make it 50 meters at an angle of 30 degrees. Got it? There's my problem. I want to add those together. Is that drawn correctly, by the way? Head to tail, that's good. Yeah, my resultant vector will be drawn from start to finish. I'm going to label that R. Maybe you draw it as a dotted line, maybe you draw it as a red line, doesn't really matter. Okay, I see this problem. I know that I need to do x and y components, but before that, before x and y components, overriding all of that is I see a funny angle first. That's the very first thing that strikes me. I see a funny angle. And what do I say? What do I repeat when I see that funny angle? I don't like funny angles. So because this diagram is going to get a little cluttered over here if I do everything there, I'm just going to take that 50 meters off to the side. Does that make sense what I've done there? I've just redrawn that 50 meters over there just so I don't clutter up this diagram too much. Does that make sense? Now, you guys remember what to do at this point, right? You just did it for like 5 questions. We draw a triangle around that 30-degree angle. This is x, this is y. Let's find x. Okay, find the components so we can get rid of that 50 meters. Cosine 30 degrees is equal to adjacent over the hypotenuse. Let's figure out exactly what that is. 50 cos 30 is 43.301. The y component is found by the sine function. Sine 30 degrees is equal to opposite over hypotenuse. Y is equal to 25 meters. Nothing new here, right? Right? Nothing new here. You guys did this for a number of questions on that worksheet already. I'm just going to block this off. That's what I always like to do in these questions, just to kind of separate it, set it aside. Now watch what I'm going to do. This is 43.301. This is 25. This is gone. I've replaced that 50 meters with a 43 and a 25. Right? Now I can deal with this like I did the homework questions, right? Now I can just say my x component, my y component. What's the x component of the first one? 0. The y component, negative 100. What's the x component of the second one? 43.301. Does that make sense? Forget, like the 50 is dead. It's 43 and 25. What's the y component of the second one? I'm going to say 25. Now, some people might say 43 and 0, and then 0 and 25. Kind of turn it into 3 vectors. That's okay. Or you can just say the 43 and the 25 are one vector, with the x component is 43 and the y component is 25. Doesn't matter. Doesn't matter. Gives you the same thing. Let's add these up. 43.301 and negative 75. Let's redraw it. You can do this, right? There's theta, by the way, at the start. There's r. You can do this. Okay, we did this a ton of times already. All we're going to do is say r is equal to square root of 43.301 squared plus 75 squared. And theta is, look at what we got. 43 is the, which side? Adjacent. 75 is opposite, so let's use tan. It's the inverse tan of opposite over adjacent, 75 over 43.301. Let's do this, both of these on our calculators here, and then I'll let you work on some questions here. Okay, 43.301 squared plus 75 squared. Let's square root that. 86.6. And an angle of the inverse tan function of opposite over adjacent, 75 divided by 43.301. 60 degrees. How would we express that? 60 degrees what of what? I'm going east and I'm going south, right? Where did I measure it from, the east or the south? I measured it from the east. So it's south from east, or we'd say south of east. Okay, what's different about this question versus the questions you did for homework? One thing. What's off in the box over here? This is the only difference, right? We had a funny angle, we dealt with it, and then we turned it into one of those questions you did for homework last night. Okay, here's the work that you're going to work on now for the next, well, for the remainder of class, basically. Questions 14, 15, and 16 on that worksheet, please. 14, 15, and 16 on the worksheet.